The echo at the edge of everything. Voyager 1's final impossible transmission. In the profound and relentless silence that exists 14.5 billion miles from Earth, a ghost from our past is whispering. It is a whisper that has traveled for over 22 hours at the speed of light to reach us, a faint digital sigh from the deepest, darkest frontier humanity has ever touched. This is Voyager 1, a spacecraft built in an age of slide rules and analog gauges, launched in 1977 with less computing power than a modern car key fob. Its mission was slated to last just 4 years. Yet against all odds, 47 years later, it persists in the cold, a testament to human ingenuity. But now it is doing something that has sent a ripple of profound disquiet through the hallowed halls of NASA's Jet Propulsion Laboratory and the global scientific community. It is behaving strangely. It has, for reasons no engineer commanded and no current model can adequately explain, turned back. Not to come home, but to look and to listen, and what it has begun to hear in the interstellar dark is echoing back to us in a language we thought was ours alone. This is not a story of alien invasion or apocalyptic prophecy. It is a story of a mystery unfolding at the very frontier of our solar system, a puzzle written in the language of plasma, magnetic fields, and gravitational waves. It is a narrative built on decades of painstaking data, recently punctuated by events so anomalous that they challenge our fundamental understanding of the cosmos itself. The official statements from space agencies speak of aging hardware and anomalous data corruption. But the raw telemetry, the numbers that don't lie, tell a different story. One of a boundary that is not what we thought, of a reflection where there should only be void, and of a countdown, silently ticking in the deep. The grandest journey, from a pale blue dot to the abyss. To comprehend the sheer magnitude of what is happening now, we must first journey back to the audacity of the late 1970s. The Voyager program was born from a celestial coincidence, a rare alignment of the outer planets, Jupiter, Saturn, Uranus, and Neptune, that happens only once every 176 years. NASA seized this opportunity, designing 2 intrepid probes, Voyager 1 and Voyager 2, to embark on a grand tour. These were marvels of their time, yet by today's standards, they are prehistoric. Each possesses a mere 69.63 kilobytes of memory, less than a single low-resolution digital photograph, and is powered by 3 radioisotope thermoelectric generators, RTGs, that even now produce only a few hundred watts, dimmer than a standard kitchen appliance. Yet with this modest power, they revolutionized our understanding of the solar system. Voyager 1 gave us the first breathtaking, detailed vistas of Jupiter's swirling great red spot and the volcanic plumes on its moon Io. It unveiled the intricate icy architecture of Saturn's rings and the hazy methane-rich atmosphere of its moon Titan. In 1990, from a distance of 3.7 billion miles, it turned its camera for one last look and captured an image that would become a pillar of human consciousness. The pale blue dot, a mote of dust suspended in a sunbeam, our entire world reduced to a single, fragile pixel. Then the probes sailed on. Their planetary missions complete, their cameras shut down to conserve power, they entered the final, most profound phase of their existence, the journey to the edge. For decades, they sailed through the Kuiper Belt and beyond, their instruments silently measuring the solar wind. The stream of charged particles flowing from the sun. Scientists were searching for a specific frontier, the heliopause. This is the theoretical boundary where the pressure of the solar wind finally succumbs to the pressure of the interstellar medium. The gas and dust that fill the space between the stars, it is the true final shoreline of our solar system. In August 2012, Voyager 1 made history. Its instruments recorded a dramatic drop in solar particles and a corresponding spike in galactic cosmic rays. The announcement was monumental. After 35 years of travel, a human-made object had for the first time entered interstellar space. But almost immediately, a nagging anomaly appeared in the data. The magnetic field direction, which models predicted should have shifted dramatically at the heliopause, had not changed. It was as if Voyager 1 had passed through a door, but found the wallpaper on the other side was identical to the room it had just left. This was the first crack in the model, the first hint that our map of the solar system's edge was incomplete. The mirror, a crack in the cosmic map, becomes a chasm. The mystery deepened profoundly in 2018 when Voyager 2, following a different trajectory, also crossed the heliopause. The data it sent back was, in its key anomalous features, a perfect replica of its twins, the same magnetic field alignment, the same density spikes, the same eerie lack of a clean transition. Two separate spacecraft, crossing the same theoretical boundary 6 years and billions of miles apart, were reporting the exact same impossible conditions. The simplest and most unsettling conclusion was that they hadn't truly left the sun's influence in the way we expected. The heliopause wasn't a sharp, clean border. It was something else, a region, a structure, a barrier. For years, a minority of astrophysicists had proposed a radical theory. The heliopause might not be a passive boundary, but a dynamic, complex structure shaped by the interaction of the solar and interstellar magnetic fields. Some simulations even suggested it could act as a hydrogen wall, a region of piled-up interstellar material. But the data from the Voyagers was pointing to something far more structured. The probe's instruments, particularly the plasma wave subsystem, began detecting subtle, coherent fluctuations. These weren't the random waves of turbulent space. They were like echoes, rhythmic and patterned, as if bouncing off an unseen, vast surface. Then in late 2023 and into 2024, Voyager 1's data stream began to change in ways that defied all conventional explanation. Its cosmic ray subsystem, operating decades past its design lifespan, started registering rhythmic spikes. They were faint but unignorable, each pulse occurring with a precise, metronomic regularity, every 11 minutes. Initially, engineers at the Deep Space Network dismissed it as systemic noise, a final death rattle from a dying instrument. But the pattern was too perfect. The amplitude of these spikes rose and fell in exact, lockstep correlation with the background oscillations of the local plasma. It was a signal riding on a signal, a whisper atop a whisper. And then came the maneuver that shattered all precedent. On a date buried in internal logs, Voyager 1's attitude control system, unused for years, fired its tiny thrusters. The movement was minuscule, a reorientation of just half a degree, but for a probe billions of miles away, with fuel reserves frozen solid in theory, this was the equivalent of a corpse twitching its finger. No command had been sent from Earth. The probe had moved on its own. It turned its main antenna, not toward our planet, but toward the source of the mysterious magnetic flux and the 11-minute pulses it had been detecting. It was an act of robotic curiosity, a gesture toward the unknown. What happened next is the stuff of scientific legend. As the probe locked onto this new orientation, the rhythmic 11-minute spikes didn't just continue, they merged. They coalesced into a continuous, steady signal, a low-frequency tone oscillating just below the range of human hearing. When the waveform was cleaned and decoded by stunned analysts at JPL, the result was a shock that resonated through the foundations of physics. The signal was a repeating harmonic ratio that matched the fundamental frequency of the hydrogen atom, precisely 1.42 gigahertz. This number is sacred in the science of search for extraterrestrial intelligence, SETI. It is the water hole, a universally recognized frequency that any technological civilization would know. More poignantly, it is the exact constant used to encode the playback instructions for the golden record, the phonograph record carrying sounds and images of Earth, a message to any potential finder. Voyager 1, it seemed, was hearing its own message, its own foundational scientific language, being played back to it. The data patterns, when analyzed, were identical to the probe's own signal profiles from decades earlier, but inverted, phase-shifted, as if they had traveled out, hit a wall, and bounced back. The inescapable, terrifying, and thrilling hypothesis began to form. The heliopause was not an exit, it was a mirror, a reflective membrane surrounding the entire heliosphere, absorbing our electromagnetic emissions and returning them like an echo in a vast cosmic canyon. The synchronization, a universe that talks back. The signal from the mirror grew in strength for 3 weeks, a haunting, strengthening tone in the void. And then, just as suddenly, it vanished. In its place, engineers, sifting through the final frames of data, noticed one last, almost imperceptible voltage fluctuation across the magnetometer. It was not random noise. It was a binary sequence. When translated, it matched the time code of the Golden Record's very first track, The Sounds of Earth, which begins with greetings in 55 human languages and one from the whale's Voyager 1 hadn't just looked back. The evidence now suggested that something, or some process, had looked back at it and had identified it by the message it carried. The scientific community fractured. The coincidence camp argued for complex plasma resonances in instrumental pareidolia, the human tendency to see patterns in noise. But the mirror camp grew bolder. Their case was strengthened immeasurably when, days after the Voyager 1 event, observatories around the world, from the European Space Agency's Deep Space Network to the Square Kilometer Array Pathfinders, began detecting their own anomalous pings. These signals were faint, but they arrived with a precise 19-hour delay after every subsequent transmission sent to Voyager 1. An MIT mathematician quickly realized the stunning implication. 19 hours was the exact light travel time for a signal to reach Voyager 1's position and bounce back from an object located on the other side of the heliopause. This was not a one-way echo. It was a two-way feedback loop. The mirror was not just reflecting. It was actively engaging, amplifying, and returning our calls. The phenomenon then achieved the impossible. The same mirrored frequency, synchronized to the second, appeared on Voyager 2's data stream. Two spacecraft, separated by a gulf wider than the entire orbit of Pluto, were now in perfect, resonant conversation with the same invisible boundary. NASA's attempts to decode this message yielded no language, no images, no mathematics as we understand it. Instead, what emerged was geometry. By plotting the frequency spikes over time, a pattern materialized, an expanding spiral intersected by precise radial lines. It looked like a map, a star chart. When astrophysicists cross-referenced the coordinates with known local interstellar clouds, the intersections aligned to form a corridor, a path stretching outwards toward the Ophiuchus constellation. The pattern repeated every 72 hours, each cycle adding finer detail, as if a vast intelligent press were slowly imprinting information across the fabric of space itself. Most chillingly, the map wasn't pointing away from us. Its convergence points, its focal lines, all folded inward, back toward the sun. It was charting Ursinun. The gravitational reply and the final silence. The crescendo of this cosmic symphony occurred in early 2025. On February 4th at 2:43 UTC, Voyager 1's systems triggered another uncommanded maneuver. This time it was more pronounced. The probe rotated 7 degrees, aligning its high-gain antenna not toward Earth, but toward the precise coordinates highlighted by the geometric map it had been receiving. This maneuver burned precious hydrazine fuel, irrevocably shortening its operational life. It was a conscious, final act. For exactly 11 minutes, the period of the original rhythmic pulse, Voyager 1 transmitted a high-powered data burst directly into the darkness, a final, focused shout into the mirror. Every dish in the Deep Space Network registered a catastrophic power drop during this transmission, followed by an absolute, deafening silence. And then, the reply came. But it did not arrive as a radio wave. It was a ripple in space-time itself, a gravitational fluctuation measured with stunning clarity by the LIGO observatories in Louisiana and Washington. This was unprecedented. A human-made object had provoked a response measurable not in electromagnetism, but in the fundamental geometry of the universe. The gravitational wave was not a chaotic crash from a black hole merger. It was patterned, harmonic, and its structure precisely matched the harmonic ratios of the hydrogen line from the Golden Record. When visualized, the waveform formed a toroidal lattice, a shimmering, pulsing ring of energy. For one fleeting moment, the universe had not just seen our message, it had sung it back in the language of gravity. What happened next was the final, chilling chapter. NASA went into a communications blackout. Public telemetry from Voyager 1 was suspended, officially due to persistent data corruption. The final compressed data packets received before the silence, when decrypted and expanded, contained a simple repeating binary code: 1 0 1 1 0 1 1, a pulse repeating every 11 minutes. But the source location data indicated this signal was no longer coming from beyond the probe. It was now inside the heliosphere, following behind Voyager 1. The mirror was no longer just ahead, it was all around. Then the Deep Space Network captured the ultimate anomaly, a second powerful signal, mimicking Voyager 1's transmission in real time, but originating from a point in empty space between the probe and Earth. For 19 minutes, it was as if there were two Voyagers, one real, one a perfect, powerful reflection, echoing each other in perfect, impossible synchrony. And then silence. True silence. Voyager 1's carrier wave faded into static, punctuated only by a faint 11-minute oscillation at the frequency of hydrogen, hidden within the final gravitational echo. Buried in the subtlest of harmonics, analysts later found a timestamp, a countdown, measured in seconds from the moment of reception. When decoded, it terminates in the year 2031. No one at NASA has an official explanation. Off the record, a senior scientist described it not as a warning, but as a synchronization marker, as if the structure beyond the heliopause, having now been calibrated by our probe and our message, is aligning itself with our solar system. It's not coming toward us, she said. It's aligning with us. Conclusion. The waiting dark. Today, Voyager 1 is silent to the public. It is a beloved relic that has finally, after a heroic lifespan, gone quiet. Its mission is recorded in history books as an unqualified, magnificent success. But for the small group of engineers and scientists who still monitor the deep space frequencies, the story is not over. Every 11 minutes, a ghost pulse echoes through the dark. It is not from the probe itself, but from the space around it, a faint, persistent echo of our first hello. This story is the culmination of human curiosity. We built a machine of metal and wire, imbued it with our dreams and our message, and sent it sailing into the infinite night. And at the very edge of our sight, at the frontier of our understanding, we found not emptiness, but a reflection. We discovered that the universe may not be a passive void, but a structured, responsive, and perhaps even communicative medium. Voyager 1's final mission may have been to show us that the greatest discovery is not finding another voice in the darkness, but realizing that the darkness itself has a voice, and it speaks in a language we are just beginning to understand. So if this journey to the edge of creation has captivated you, if you now look up at the night sky and feel a shiver of anticipation, wondering what else is waiting to be discovered, then you cannot afford to look away. The clock is ticking. 2031 approaches. Subscribe to this channel. Because when the silence from the edge of the solar system breaks again, and the data suggests it will, we will be here to decode the next message, and we will finally learn if we were the first to reach out, or merely the last to realize we were always being watched, and now finally acknowledged. The echo is waiting for our reply. What will we say next?